Okay, now let's try to solve some examples from the textbook one by one. Let's try to understand this large sample testing better. Suppose that this is your example one. I'm sorry. So there are some, there's a factory that produces screws with the population mean of 100 millimeter length and with a standard deviation of 2 millimeters. This is, you can say that this is known before. You know that it has a production like this. And there had been a fix to this machine or machinery that produces those screws. And you get 9 samples. 9 samples with the arithmetic mean of 102 millimeters. That is the case. And the thing is, the question is it still calibrated or not? Calibrated or not? In other words, does it require calibration? In other words, is it producing different than 100 millimeters? Only with that sample set, you need to decide on this. And of course, we need to give you the rejection region here for alpha equals 0.05. This is the probability for type 1 error, right? Type 1 error probability, in fact. That's it. So what was type 1 error? Rejecting H0. In fact, that is true. That's the case. So build your hypothesis, null hypothesis first. You remember those steps. H0 is mu equals mu0, which is 100 millimeters. All right. And your alternative hypothesis in this case is, look at this. Is it calibrated or not? It can be less than or higher. So both of them are within our interest here. So mu is not equal to 100 millimeters would be your alternative hypothesis here. And your z value here in this sense should be x minus mu0 over standard deviation of your sample set, and that should be this one. You already have these values, and 2 over square root of 9. We can put this comfortably right here, right? Because it is already population standard deviation that we have here. It helps us a lot, so it's something wonderful. And the result would be what? Your C value, in fact, would be exactly 3. And look at this, interesting values for 0.5 here, 0.05 here, that should be 0.025, that should be 0.025, right? So, and what are those values? Let's check. Oh, it's already right here. It's 196, right? This is dealing with. So it means that your C1 and C2 here should be 196 and minus 196 right here. But where is your C value here? It's at 3, right? It's something, if it is like, suppose that that's 0, and suppose that this is 196, this one. And where is your C located? It's around here, right? It's this is your 3 point, so it means that it is in the rejection region here, and H0 is rejected. So your answer should be like this: H0 rejected. That's your answer. That should be your answer. And the answer to your question is calibration is required. So it's not equal to 100 millimeters anymore, and the calibration required. With what confidence, or what is your alpha here? 95%. Okay, so you're speaking like this. That's the idea with one of the examples from our textbook. Now let's solve another example, namely the example 2 here, again from our textbook. So daily production at a factory is 880 kilograms daily production. All right. A new method is proposed, and they say that it increases production. Okay, you need to test this. So but look, proposes increased production. Okay, a new method. And you take 50 days production as sample, n equals 50 days production as sample, and the average was this much of kilograms, right? 892 kilograms with the standard deviation of 21. Now you need to, you're curious about whether it increased, the method really increased production or not. If you look at this one, yes, it increased, but is it statistically significant? That's what you're looking for. So your alpha should be taken 0.05 here. Just keep in mind, if I don't give you anything, or if they don't give you anything in the question about your rejection region or confidence value here, just take it as 0.05 or 95% confidence. Okay, this is like default value. Okay, you can consider this as a default value. Okay, what we're doing it is for 0.05, and your H0 hypothesis should be built like this: mu equals 880 kilograms, and your alternative hypothesis should be mu is, look at this, more than, because what we're testing is whether it increased the production or not it is different or something like this, whether it increased the production or not. So it means that you're curious about only this region, and this is particularly 0.5, so it means that you will be left here with 0.45, and the corresponding value for 0.45 was what? Corresponding value for 0.45 was it was between these two values, right? 1645, right? All right, 1645. Okay, so your critical value here should be 1645. This value right here, 1645. All right. So your z equals, where is my c value here? Z is x minus mu 0 over our standard deviation, and it should be this minus your population average. 21 is your s over 50. Since your I mean, samples are larger than 30, you can assume that it approaches to normal distribution. So you can also use this value instead of your population standard deviation. That's why we're using it comfortably right here. No problem. And in the end, so your Z will be, after you make the necessary calculations, 4.04. So where is your 4.04 is located? Something way far from here, right? It should be something like this. So since this is your 0 point and this is your 1645, so where is your 4 located here? If it is 1 point, so your 4 is something around here, right? Look at this. So it means that it is in the rejection region, so the answer is H0 is rejected. If H0 is rejected, then it means that your alternative hypothesis holds. Yes. So the answer is yes. Yeah, this new method is has increased your production capacity with the confidence of we're saying this with a confidence of 95%. Okay, and the probability of making a type 1 error here is, in our words, is 5%. With this confidence, we're concluding that this new method has increased production. Now let's solve the next example, again from our textbook. So let's continue with the third example. It is known that in a specific population, smokers among men are 60%. Smokers among men are 60%. Okay, we know this from our previous studies, previous work. Okay, anyway, and there are 200 lung cancer patients of whom 140 of them admitted that they smoke. Okay, there are, okay, of course, men. 200 male lung cancer patients, between 200 lung cancer patients, males, 140 of them admitted that they smoke. The question is it more frequent to see smokers in lung cancer patients? Okay, is it more frequent to find smokers in lung cancer patients? Okay, more. Be careful, this is more. So it means that we need to build our hypothesis like this. It is solving almost half of the question, right? So your probability is equals 0.6, and in your alternative hypothesis, your probability, just pause the video and think about it. What will you put here? Either this or this or this. Just pause the video and think about it. Okay, you will put here, since it is more larger than, okay, and your sample P is this one over this one, which is 0.7. what we're dealing with. Okay, we forget. We forget. So your alpha is 0.1 this time. This is what we're going to, this is the rejection region that we will build our test on. So the thing is, your, sigma p with a hat is p q over n, which is what you have here. Look at this. These are population parameters. So it is 0.6 times, just be careful about it, 0.4 times over 200 is your n, and that is 0.346. This is your sigma. And what is your z here? P minus P0 over PQ over N here. So it would be 0.6 minus, 0.7 minus 0.6 over your sigma P with a hat. Okay, this one. And the result will be 289. All right, now I know that I am located, this is your 0, and I am located at 289. But is it rejected or not? Am I in the rejection region or not? So it means that I'm looking for that critical value here, which is 0.1, but what is left for here, it is 0.49, right? So I will look at the corresponding value for 0.49 here. Where is it? 0.49 is, where is it? It is somewhere around here, right? Between 2.32 and 2.33. But I think a bit, just between them, right? It is, it's a bit more close to, maybe this value could be interesting, right? 2.36. Okay, I'm just putting some value between them. 2.326, I think that makes sense. Okay, 2.326, and let's take it right here. So that value is 2.326, and where is it located? Right here. It is 2.326. Look at this. This is your rejection region, and you are at the rejection region. So your H0 is, hypothesis is rejected. It means that rejected with what? 99% confidence. We're talking about this. So your H0 is rejected. It means that your H1 holds, and there are more smokers in male lung cancer patients. You can conclude like this. That's the idea. Let's solve another example here that we will compare the difference between two populations, the This is the fourth example from our textbook. In a bird population, we wonder whether male and female birds weights the same. Weights are the same. Okay, so this is what we're curious about. So we need to, okay, let's define our rejection region first for alpha 0.5. This is what we're wondering, and of course we need to take sample for this. These are given to us, male birds and female birds. Here their sample size is 125 to 85. This is what you could find, and their mean is given here with 92.31 grams for the males and 88.84 grams for the females, and their variances are consecutively this one and this one. Okay, slightly more variance for the females. Now we need to build our zero hypothesis first, your null hypothesis, and then we need to define our alternative hypothesis. Your H0 should be something like this, right? So the default one. Okay, so that means that mu1 minus mu2 will result in 0. That's it. And for your alternative hypothesis here, what we're trying to do is what? Whether the same or not. Okay, you go back to the question and you can see that is a two-tailed one. So it means that mu1 minus mu2 is not equal to 0. So in this sense, you immediately understand that what we're trying to do here is two-tailed. And since this is 0.05, it means that what you have here will be 0.025 for here too. And you need to find this critical rejection region value from what? Your Z table. All right. And okay, let's define it first. Before we proceed further. So it means that what you're going to do, look at, will be this one to add up to 0.5, right? That's why. So we're going to look at 0.475 here, which is right here. I find you. It is right here, 196. All right. So it means that our let's say critical values here are plus 196 and minus 916. So if we either fall far from these locations, it means that we're in the rejection region for H0 and we will reject H0, and that will mean that their weights are different. That's the idea. So let's do some calculations to transfer our data to standard normal distribution table so that we can use that table efficiently together. Minus 0, okay, mu1 minus mu2 is 0 in your H0 hypothesis, and x1 minus x2 here as the standard deviation. You can put it like this. But the thing is, you need to keep in mind that if you have a reference, two populations, standard deviation here, this is how you calculate it. It is given in the textbook as well. Square and 1 plus square and 2. All right, so what you have here will be 0.22 over 125. This is for the male birds that you have here, and for the female birds you will have 6541 divided by plus 6541 divided by 85 female birds, and in the end you will have 0.49 plus 0. Please repeat those calculations. I calculated them for you with my calculator, but of course they can be wrong. Of course, a double check would be very nice. So that's it. That's your variance in this case. Okay, and then you try to find out this one, which is pretty straightforward. 92 minus 98.84, which is 347. All right, so what is your Z here? What's your curious about? 347 over this value 113, which is equal to, oops, where is it? It's equal to, oh, it looks like our P number, right? Anyway, but the thing is, what we're interested in here, just remember our critical values here, 196 and 196 here, minus 1, see, plus 1, see, this is your 0 point. Okay, what we're curious about is, are we rejecting this hypothesis or not? Our null hypothesis or not? Okay, where are we located here? 3.14. We are here, so that means that we reject H0, right? We reject H0, so this is the answer to your question. H0 is rejected. H0 is rejected. So their weights are not equal. Not only, okay, your conclusion is their weights are not equal. This is enough. You finished the question here. Their weights are not equal. But there can be another conclusion here. The side conclusion, or at the same time in parallel. Male birds are heavier here as well, because you are on the right hand side, not here. It means that if you fall to this side, that means that they're not equal. Plus, female birds would be heavier if you were here, but since you're here, of course, this is a, let's say, bonus conclusion from this. Male birds are heavier as well. This is what you see. But of course, I'm not asking you for this, or the question is not asking you for this, but this is something extra. All right. Okay, now the next one will be our last example about large sample hypothesis testing. Let's take a look at the example 5 here. When they look at the hospitalized males and females, humans, okay, hospitalized males and females, when they have taken 1,000 samples from both males and females, and they figured out that 52 of males have heart disease, for males, and 23 of females have heart disease for females, okay, females. So if we give them probability of P1 and P2, now the question is heart disease more frequent in hospitalized males than hospitalized females? Okay, is heart disease is more in hospitalized males than females. There are some crucial words here. This one is, we need to focus on this, but I will talk about this hospitalized as well later. Okay, let's try to find this out and build our null hypothesis and alternative hypothesis first. But before we proceed further, what is our alpha? If nothing said, we accept it as 0.005. But again, for this case, they give it as 0.005 as well. And that's it. So our initial hypothesis is no difference, right? So P1 equals P2, which results in a difference of 0, right? This is your null hypothesis. And your P1 and P2, how are they related? Is heart disease more in hospitalized males? So it means that what we put here would be one-tailed hypothesis testing here. So it means that your P1 minus P2 should be larger than 0. So it means that what would be my threshold value here? So you see it is one-tailed this time, and all your 0.05 is here. So it means that what has been left here would be 0.45. And what is this critical value here? 0.45. Let's go back to our lovely table, which is 0.45 is, where are you? Okay, I think, oh, you're hiding here between them, right? Between 164 and 165, never memorize, okay? 165, which is 645. Wonderful, wonderful. This is what we're looking for, and this is your critical that alpha here, which is 1645. If we hit anywhere larger than this on the right hand side, we will reject our H0 hypothesis. That's the idea. All right, so your P1 estimate is this one over 1000, which is 0.2, and your P2 estimate is for the females 23 over 23. Okay, Michael Jordan, right? Anyway, 0.23, great. And P1 minus P2 is 0 minus 0.23, which is, this is your difference that you should put in your pocket. Now, you need a general P here while you're dealing with the standard deviation here. You need general P here, because why? You're assuming that their difference is 0. So you need general P here. So when you combine them, your P with a hat would be x1 plus x2 over n1 and 2. See, they're combined here because we will put it in the denominator. 23 over 1000 plus 1000 here, which results in a P of 75 over 2000, which would be 0.0375. Okay, this is your combined P, and your variance here for the difference should be P1 Q1 over N1 plus PQ Q2 and 2. Okay, and you put here P times Q because you combined them, 1 over N1 plus Oops, what is this? It's very silly, right? Okay, I don't want to look silly. 1 plus 1 over n2. All right, that's wonderful. Where you suppose that, I mean, that's why we're doing this, right? But we suppose that H0 true, and we're trying to reject this. That's why we combine the probabilities here. That's the idea. All right, so when we put them in their correct locations, correct positions here in the formula, minus, okay, you assume that they're not different here. You assume that there's a difference. So, of course, you need standard deviation, not the variance. P times Q with a hat 1 over N1 plus 1 over N2. So that results in this one minus this 1 over, okay, square root of what? 0.0375 times 0.9625. Look at this. This is the complement of this one, right? That's it. And times what you have here is 1 over 1 over multiplied by this, right? 2 over 1000. So when you make the necessary calculation here, you get Z as 341. Please make the calculations with your own calculator as well and double check the results. So now when don't rush, just write everything. This is your point and this is your rejection region, which was based on what? 1645, right? This is your 1645, but what we achieve here after our testing is something right here, right? 341, it is located here. See, that's why I'm here. So I reject H0. So your answer should be H0 is rejected, right? H0 is rejected. So there is more. What does it mean? So the answer to your question, there is more heart disease in hospitalized males than females. All right, we see this hospital, but be careful, but be careful with your conclusion. In hospitalized, what we're talking about is between hospitalized people. Within those hospitalized people, males are found to have more heart disease than the females. But be careful, maybe females don't go hospital as much as males do. So if you generalize this as a conclusion males have more heart disease than females, that could be something tricky, something that a weak conclusion that you can draw. Be careful. There is more heart disease in hospitalized males than hospitalized females. That's what we can reach as a conclusion here, okay? That's the difference, and that's what we need to be careful about in any kind of hypothesis testing or statistical analysis, statistical inference situations, okay? This is what we're trying to tell you about this, okay? Just be careful and just keen on the details of the text of the question or text of the problem. Okay.